Hypothesis test for a population proportion. This is going to be some fun stuff, folks. Hypothesis testing is sort of the heart of this class. It's going to be a little confusing at first. Don't get frustrated. Just watch the videos. Watch them a few times. It's going to make sense. And, I think in the beginning I referred to this as 10.2. Just ignore that. This is hypothesis testing for a population proportion. Okay. Have fun, folks. Okay, folks, hypothesis testing, chapter 10, section 2. Feel free to read chapter 10, section 1. I think they over-explain everything, and 10.1 would make more sense after 10.2 makes sense. Yeah, I know that's a weird idea. I just feel like we'll be better off just learning how to do a hypothesis test, getting the correct answers, and then when you go back to 10.1 and review the concepts, they will make more sense. Okay, there's going to be a lot going on here. Bunch of videos for this section. Thinking caps on. Okay, so some terminology first. Hopefully you have the worksheet out. The H sub 0. H sub 0, that's our null hypothesis, sometimes called H naught. Naught's just a fancy way of saying 0. Or H sub O. So that's our null hypothesis. That is what we are assuming to be true. Our alternative hypothesis, our H sub 1, some books, or if you're watching other videos online, sometimes they call it the H sub A for alternative, HA, HOHA, HOH1. So HA, H1, same thing, alternative hypothesis. That's usually the idea we're interested in. We'll see more of this in a second. The significance level, we are going to represent with the symbol alpha. So sometimes they'll say the significance level is 5%, or they might say the alpha level is 5%, or they might say the significance level is 0.05, which means the alpha is 0.05. 0.05, 5%, same thing. So the significance level is usually 5%. The problem will usually tell you what the significance level is. Sometimes it's 0.01 or 1%. It could be anything, whatever the problem says. But if they ever forget to mention, then just assume the significance level is 5%. Okay, so this first problem we're going to do it 3 different ways. Oh my. I think we'll do the p-value approach first, and then the p-value with the calculator, and then lastly we'll do it with the classical approach, the rejection region. Why do it all 3 ways? This way, so we understand what's going on. This way is a little bit magical. And then we do it the classical way because there's going to be other tests in the future that don't have the magic of the calculator. So we need to understand the rejection region approach. Okay, a lot going on, I know. Okay, well let's just pause there and get ready for problem number 1.